Good morning, students. This session is for class 12th physics. Okay, we are going to solve this question given in this circuit. You can see there is a circuit which contains a battery of 10 volt, a resistance 4 ohm, another resistance 15 ohm, another resistance 30 ohm, another resistance 15 ohm arranged in a circuit. You have to find out potential difference between point A and V. So you want to find out VAB is equal to what in this circuit. Okay, this is your question. So students, first we have to find out the net resistance and current in this circuit. Okay, so let us consider the current in this circuit is I. So it will be break here. Suppose at this point it is I minus I1. Okay, so here it is I1. Now it will break here. Suppose in this branch it will be I2, then in this part it will be I minus I1 minus I2. Okay, now at this point this I1, this I minus I1 minus I2 and this I2 will be added together and gives current I. Okay, so let's first find out the value of resistance, equivalent resistance. Okay, so in this diagram you can see this 15 ohm, this 30 ohm and this 15 ohm are parallel combination. Why? Because you can see this resistance, one end of this resistance is connected with point B. Similarly, one end of this resistor 30 ohm is connected with B, and one end of this 15 ohm is again from point D, it is connected at B. Okay, similarly the second end of this 15 ohm resistor is connected to point C, second end of this 30 ohm resistor is connected to point C, and second end of this 15 ohm is connected to C. Okay, it means these three are connected to point C. It means these 15 ohm, this 30 ohm and this 15 ohm are in parallel combination. Okay, so we can write 15 ohm resistor, then 30 ohm resistor, and then again 15 ohm are in parallel combination. Okay, so equivalent of these is given by 1 by R1, because this is the formula for parallel combination, is equal to 1 by 15 plus 1 by 30 plus 1 by 15, or you can write it 2 by 30 if you multiply 2 and 2, plus 1 by 30 plus 2 by 30, it will give 5 by 30, it means 1 by 6, or you can write R1 is equal to 6 ohm. Since 1 by R1 is equal to 1 by 6, so R1 is equal to 6 ohm. Okay, now you get R1 is equal to 6. Now the equivalent circuit is given by you can draw the equivalent circuit for this. So if you connect here, there is a resistance of 4 ohm. Now these three resistances are replaced by only one resistor of 6 ohm. Okay, so we can use only a 6 ohm resistor here, and we will connect it here. And this one is of 10 volt. This one is 4 ohm. According to the question, this one is 6 ohm. Okay. Now net resistance of this circuit is, I hope you know, 10 ohm, because these two are in series. You can see this 4 ohm and this 6 ohm are in series, because the one end of these two resistors are connected at this point, and there is battery between the second end of the two resistors. Okay, so I hope you understand. So since 4 and 6 ohm, we can write 4 and 6 ohm. You can write ohm here, are in series. So equivalent of these two is R2 is equal to 4 ohm plus 6 ohm, that is equal to 10 ohm. It means this R2 is the net resistance of this whole circuit. Okay, so you can again get a circuit like this, which contains a battery and only one resistance at the place of these two, which is equivalent of the 2, and this one is 10 volt. Okay, so we get equivalent resistance of this circuit, but actually this is not our aim to find out the equivalent resistance only, but this is the part to complete our aim. Okay, this one is a step. Now we can find current flow in this circuit here, that is I. So current in this circuit, in this part C, you can write it B. So in C, current I is given by, we can apply Ohm's law, V is equal to I into R2, because R2 is equivalent resistance. So since V is 10, we can write 10 here, then we need, or we don't know I2, then R2 is 10. Then after calculation you can write I is equal to 1 ampere. Of course ampere is unit of current. Okay, so I is 1 ampere. Since if we see this diagram, you can see this 10 ohm is broken into two parts in series, 4 and 6 ohm, and in series combination current remains same, so I remains same here. It means 1 ampere in 4 ohm and 1 ampere in this 6 ohm. If you add these together, that is 10 ohm. Okay, or it is directly 10 ohm, and current in this 4 ohm and this 6 ohm remains same, that is 1 ampere, because these two are in series. Okay, you can see in this 10 ohm current I is equal to 1 ampere. Okay, now if you break this resistor in two parts, suppose this half is 4 ohm and this one is 6 ohm, but current remains same in both of them. So you can see here this 4 ohm and this 6 ohm current remains same, that is 1 ampere. Okay, so current here in this part is also 1 ampere. Okay, and here it is 1 ampere. Now we are going to see the first circuit. It means this current I which is flowing in this part is 1 ampere. Okay, now combination of these three resistors are 6 ohm. If we take only one resistor of 6 ohm at the place of these three, current in that capacitor, it means you can see this one, it remains same as in 4 ohm. Okay, remains same as in 4 ohm. You can see here in this 4 ohm and in this 4 ohm current is 1 ampere in 1 ampere. But if you take only one resistor of 6 ohm at the place of these three, the current will be same 1 ampere. But if this 6 ohm resistor is broken into these three parts, okay, 1 2 3 15 30 and 15, after using formula for parallel combination you will get same result, that is 6 ohm. If it means this 6 ohm can be broken like this. Okay, so in each part current will be different, but we know that because these are parallel, so potential difference across each resistor remains same. Okay, so potential difference across each resistor remains same. Potential difference across each remains same. So you can see here the potential across these point, that is A and B. This is point AB is in this circuit. After, if you break this 6 ohm into three different resistors like this, you will get the point C and D here in this part. Okay, but AB is actually this point and these three resistors are in parallel, so potential difference across 15 ohm is equal to across 30 ohm is equal to across 15 ohm. Okay, so you can calculate the potential, and this potential V is equal to current I into R means this 6 ohm. Okay, so V is equal to, you will get here, so it will be 1 into 6, that is 6 volt. So I hope you understand the potential difference across this AB is 6 ohm. This is the question, what is potential difference across AB? So across AB potential difference is 6 volt. I hope you understand. Thank you.